All right, today we'll be talking about right triangles. First, and we're going to talk about how they're similar. First, we'll look at theorem 9.1. If the altitude is drawn to the hypotenuse of a right triangle, so let's look at our triangle over here. We have a right triangle, angle C is that right triangle. If it is drawn, the height, to the hypotenuse of a right triangle, then the two triangles formed, so this one and this one, are similar to the original, the big one, and to each other. So if we put that in similarity terms, you would say triangle CBD, so CBD, and triangle ABC are similar to one another. And then triangle ACD is similar to ABC. And then, additionally, triangle CBD is similar to triangle ACD. So the two small ones are similar to one another, and the small ones are also similar to the large one. Let's apply this. So roof height. A roof has a cross section that is a right triangle. So we have that angle Y right there as the right triangle. The diagram shows the approximate dimensions of the cross section. So we have 5.5 meters, 3.1 meters, and 6.3 meters. And we have an H for height because we don't know what that is. They want us to identify the similar triangles. So the best way to do that for me is to draw them out and break them apart because it's kind of hard to see them when they're combined. So the first one I will draw, I'm going to go like this. I want them all kind of in the same direction because it's easier to see. So I have my right triangle here, which is Y. And then I'm going to have my X and my Z. And so for that one, your hypotenuse is 6.3 meters. And this leg, the ZY one, is going to be 5.5 meters. And the XY one is going to be 3.1 meters. So that's the large triangle. Now let's break apart the other triangles. So I'm going to let's do the next biggest one, which is this one right here. And so my right angle is at W now. And the top is going to be, let's see, W. And then we have Z and Y. Don't ask why it just changed colors. So we have our W, Y is our height. We don't know what that is yet. And we have our ZW, which we don't know yet because it's 6.3 minus something because we don't know the other side. And then we know that our ZY is going to be 5.5. Okay, let's do our smaller triangle. So our smaller triangle, we have W as our angle, we have Y on top, and we have X here. And so we go like that. And our WX we don't know. We know this is height, H, and we know this is 3.1. Okay, so for the similarity, we're going to list them as follows. So we have triangle X, Y, Z, and I want to do it in a certain order, so I started here, X, Y, Z, wrong triangle. Let's see, oh, the big one, I'm sorry, X and Y and Z is similar to triangle Y, Z, W. So we have Y, Z, W. And it's also similar to triangle X, Y, W. So X, Y, W. Sorry about that mistake. So when they ask the similarity statement, that is what you would put. And then we want to figure out the height of the roof. And the way you do that is you just set up your proportion. So I chose to do 5.5, so I have the ZY to the height of this one over here. And then I use the hypotenuse, 6.3, and I use the other hypotenuse over here, 3.1. When I multiply that out, it'll give me 6.3h equals, and 5.5 times 6.3 is 17.05. And when I divide it out, it gives me approximately, because I'll have to round, 2.7 meters. So that's how you find the missing height. Okay, let's go on to our next concept, and that's using the geometric mean. And we've talked about the geometric mean a little bit before. Let's look at our theorems. In a right triangle, the altitude from the right angle to the hypotenuse, so CD right here, divides the hypotenuse into two sections. So here's the first section, here's the second section. The length of the altitude, so we have our altitude here, is the geometric mean of the lengths of the two segments. So we have BD, so this is our second segment, we put BD, and then you put your height, CD, and it is equal to CD again, but then your other length, AD, and we'll apply that in A. So I'm going to put 9.2 right here. For theorem 9.3, in a right triangle, the altitude from the right angle to the hypotenuse divides the hypotenuse into two segments. The length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. So you put your AB, so you have your hypotenuse, AB, and then you do one of the legs, AC, and you put equals, and then you do the other leg, or the same leg, AC, over AD. So that is 9.3, and we'll apply that down here. So let's do A together. So when we do this one, we're going to look for, it's dividing it into two segments. We have 3 and 5, and then our height is h. So we start with one of our segments, so 3, and then we put it over our height, which is x, and then we put our height again, and then we put our other segment length. And then we solve for it. So we have x squared equals 18. And then you do the square root, and x is going to equal 3 square root 2 when you simplify. Okay, now let's look at this one. It's a little trickier. So we don't have our height, but we're trying to find the leg. So the way that we do that is we want to do this segment, so 5 plus 2, which is 7. And we want to put that over the missing segment, y. And we want to do our missing segment again here. And then we want to do it over part of our segment, so 2. So we have y squared equals 14. And then you do the square root, and 14 does not simplify into anything that you can do a perfect square out of. So you get the square root of 14. You could do a calculator and get a decimal amount if you wanted to, but I'm not requiring that. All right, that's it for similar right triangles. See you later.